Section 2.8, Inequalities and their graphs. Inequalities is a mathematical sentence that contains these symbols: the greater than sign, the less than sign, greater than or equal to, less than or equal to, or not equal to. Here are some examples of these sentences. Number one, x is greater than a negative 5, and this is how that is written and also stated. Number two, here we have 4 is greater than or equal to k, but in math we like to actually present the variable first. So I will say k is less than or equal to 4, and it's written this way: k is less than or equal to 4. The solution of an inequality is any number that makes an inequality true. For example, number 1, we have x is greater than a negative 5. Therefore, what are the possible solutions of this number? Any number that is greater than a negative 5. That would be a negative 4, a negative 3, a negative 2, 0, 1, and also continuing to infinity. And it also would include any decimals and fractions in between these numbers. And it would also contain any decimal or fraction between a negative 5 and a negative 4, but would not contain a negative 5, as x needs to be greater than a negative 5. Number 2, I have 4 is greater than or equal to k, or k is less than or equal to 4. That's the way we need to look at this. K is less than or equal to 4. Therefore, the set of numbers that would be a solution to this inequality would be any value that would be less than or equal to 4. So I would say 4, 3, 2, 1, 0, negative 1, and continuing to infinity on the negative end. And it also would contain any fractions or decimals in between these integers. And also remember, since this is k is less than or equal to 4, 4 is part of the solution. Now, what we want to do is graph the inequalities. And we want to graph them on a number line. Remember, the solution is a set of numbers represented with shading. And also, the starting point is determined by the type of inequality that is given to us. So let's take a look at our specific symbols. A starting point is not part of the solution. A starting point is not part of the solution when I'm either given a less than or greater than sign. Notice there is no equality. And when we do that, we use an open point for the starting point. In other words, a circle, but it's not shaded. So we use an open point for the starting point for a less than and a greater than sign. And that tells me the starting point is not part of the solution. And that is the same as we shown on the last slide, that x is greater than negative 5. A negative 5 is not part of the solution. Down below, we have a starting point is part of the solution if I have less than or equal to or greater than or equal to. And you can see our starting point would be represented with a circle or a point, but it's fully, completely shaded. And that's called closed. Use a closed point for the starting point. Use an open point for the starting point. Unshaded, open point, not part of the solution. Closed, which is shaded, which means it's part of the solution. When it's shaded or closed, the starting point is part of the solution. Here I want to graph the solutions of each inequality on a number line. Number 1, x is greater than a negative 5. So I'm going to draw a number line. And I don't need to start at 0 on either end. I can go right to a negative 5 right in the middle, a negative 5. And then I know I have a negative 6, a negative 7, and down below I have a negative 4, a negative 3, and a negative 2. Because if I start with large numbers, 125, I don't want to start at 0 and go to 125. Even though this isn't that big, it's a negative 5, I want to show my negative 5. Now I have x is greater than a negative 5. Since this is not an equal to, I have an open point at a negative 5. And now I want to represent all solutions of x that are greater than a negative 5. So I shade to the directions of all values greater than a negative 5. That means it's all the integers, and as I stated before, it's all the numbers in between a negative 4 and a negative 5, between a negative 4 and a negative 3, which is all the fractions and decimals. So this is x is greater than a negative 5. Number 2, m is less than 0. Again, I'm going to start here. 0, negative 1, negative 2, negative 3, 1, 2, 3. And now I have m is less than or equal to. Since it's an equal to, that means it's a closed point. So you can see the difference. No equal to, so it's open or unshaded. Less than or equal to means it's closed or shaded. It means it's part of the solution. And then I shade every value to the left less than 0. That represents all integers and fractions and decimals less than 0. Graph the solutions of each inequality on a number line. Number 3, 17 is less than or equal to k, but we want to state that as k is greater than or equal to 17. And of course, I don't want to make a number line starting at 0 and going to 17. I'm going to put 17 right in the middle. 17, 16, 15, 14, and then greater, 18, 19, 20. And I take a look at my inequality. It's k is greater than or equal to, so I need a closed point at 17. And that is because 17 is part of my solution. K can equal 17. And now I'll shade everything to the right, or all values that are greater than 17. That represents the set of solutions for that inequality. Number 4, p is less than a negative 31. So again, I don't need a massive number line starting at 0. I just put a negative 31 right in the middle. And then everything to the left would be less than negative 32, negative 33, negative 34, and to the right would be a negative 30, a negative 29, and a negative 28. And I take a look at my inequality, and at a negative 31, I need an open point because p does not have a solution at a negative 31. Negative 31 is not a solution for p, but I need all values less than a negative 31. That's why you want to read that with the variable first. Because if you read with the variable first, it says p is less than a negative 31, and that gives me the direction I want to shade. All values less than 31, negative 31. Now, on these examples, I want to write an inequality for each graph. So number 1, I can take a look at the point that we're at. It's an open point. So I know that I'm going to have either a greater than or less than sign, but not equal to because it's open. And here, values to the right are being shaded, so therefore it's going to be a greater than. And I can make any variable name up I want. So I could just put down an x. X is greater than, and then I state the starting point, a negative 2. X is greater than a negative 2. Starting point at a negative 2. Symbol tells me that's an open point. Greater than tells me values to the right, or values that are greater. Number 2. Here I have a closed point. So I know that's going to be a less than or equal to, or a greater than or equal to. My shading is to the left, which is less than. So this is less than or equal to. And I'll make up another variable, p. P is less than or equal to the starting point, negative 1. P is less than or equal to, closed point, starting point, negative 1, and less than means shading is to the left. Write an inequality for each sentence. Graph the solution of each inequality. G is at most a negative 12. So what does this mean in a solution of an inequality? G is at most a negative 12. That would tell me that G can't be bigger than a negative 12. So G would have to be less than or equal to a negative 12. At most would mean that it can be a negative 12, but it can't be any greater than a negative 12, which means it'd have to be less than. So now I would graph that. Negative 12, negative 11, negative 10, negative 9, negative 13, negative 14. And Less than or equal to means it's a closed point at my starting point. And G is less than, I shade to the left. Again, I want to write an inequality for each sentence and graph the solution of the inequality on the number line. Number 2, a number K is at least 12. It's at least 12. In this situation, K is going to be at least 12. When that is the case, something is at least 12 means it can be 12 or greater. So K is greater than or equal to 12. Now all I need to do is to graph that. And K is greater than or equal to 12. I'm going to shade that. K is greater than. So I have a closed point, and then I graph or shade all values to the right. Write an inequality for each sentence. Graph the solution of each inequality on a number line. Number 3, Z is not more than 20. Z is not more than 20. So Z is equal to 20, but not more than 20. So it's less than or equal to. And less than or equal to, I have a closed point. And I shade all values less than 20. And the last one of these, a number P is negative. A number P is negative. Well, P has to be less than 0. But can it be equal to 0? 0 is neutral. It's not negative. So P cannot be equal to 0. So P is negative would mean it is less than 0. So I have an open point at 0 and shade all values to the left, which would make those values for P negative.